and welcome to an algebra tutorial video. We are learning about graphing linear systems of equations and being able to approximate what the solution is from a graph. So here I've got a linear system, and we can tell by my little two equations and the little bracket connecting them together. One of them is in slope-intercept form and the other is in standard form. What we're going to do is let's graph both of these, see what the linear system looks like, get an idea of what's going on. We're going to see that the solution to the linear system is where my two lines intersect, is where they cross each other. So we're going to graph them and identify the point of intersection and see how well it fits the solution there. All right, so the first one, let's start with the equation on top, this one right here. So I've got y equals 1/3 x minus 4. Well, it's already in slope-intercept form. Remember, y equals mx plus b. So b is -4, that's my y-intercept. So I'm going to go down 4. That's where that line crosses the y-axis. Now my slope, m, is 1/3, so I'm going to go over 3 up 1. It's the rate of change. It means every time I change 3 for x, I increase 1 by y. And there we go. I can now switch to line mode. There we go. Let's go that way. And over that way. All right, we just graphed the first equation. The second equation is a little bit different. So we have it in standard form. Remember, ax plus by equals c. So we're getting a little bit of review of linear equations here. This is the second equation. So there's a couple ways. I could turn it into slope-intercept form. Again, solve for y, rearrange it. We could subtract ax from both sides and divide by b. We can also use a different way of graphing using the intercept method. I could put zeros in for x, zeros in for y, find the x and y intercepts, and then graph those 2 points. So that's what I'm going to go ahead and do just to make it a little bit different. We've already done slope-intercept form, so let's do the intercept form. So I'm going to put 0 in for x and solve for y. And 4 times 0, so I end up with 5 times y equals 10. Which means once I divide by 5, my value for y equals 2. So I've got the point when x is 0, y is 2 in my relationship here, and that's that point right here. Now I can do the whole same thing, I can do it over again, but this time let's put 0 in for y and solve for x. So we've got 4, I'm going to do it up here because I want to save that space down there. So we've got 4 times x plus 5 times 0 is equal to 10. Well, that's 4x equals 10. And when I divide both sides by 4, I see that x ends up equaling 2.5. So we've got the point when x is 2.5, my y value is 0. We just found the x-intercept. So we have the y-intercept, the x-intercept. That point is going to be right here, 2.50. All right, 2 points is enough to make a line. So let's go ahead and sketch this one out to roughly right about there. And then back over right about there. All right. So there we go. We've sketched our linear system of equations. Both lines have the same x and y variable. And we want to find out, well, what is the solution? The solution to the system is the intersection point of the graph. So if I was to come over here on the graph, this point right here where my two lines intersect, if I can find that intersection point, the coordinates, that's going to give me the x and y value. So reading as well as I can from that point, I would say that this point has an x value of just a little less than 1, 2, 3, 4, 5, 6, a little less than 6. So I might guess it's about, let's do 5, just guess approximately 5.8. And then the y value is down right about -2. So I would say a reasonable guess for the solution to this linear system is this point here. When x is 5.8, my y value is -2. Now that's approximately the point. If I put those values in for x and y, that's what's going to make both equations true. Now this is approximating for a graph. So remember, this is an approximation. I just hand did this graph, so I'm feeling like I'm no way going to assume that's an exact answer. It could be 5.75, it could be 5.6, it could be 5.9. I just kind of freehand did this graph, but it helps me to give an idea what's going on. And later on, as we get into more algebraic methods of working with linear systems, solving things out, getting more complicated to find exact answers, sometimes it's really helpful to have a graph just to kind of tell if we're on the right track or check our work or make sure we're doing things good. So graphing is really important. It's really helpful, but keep in mind, sometimes we just are finding an approximation. We might not be finding the exact answer. But there you go. The solution to when you're graphing linear systems, we're very interested in finding that intersection point. That is the solution. And most of everything we'll be doing with linear systems is based around trying to find the coordinates of that point.